At the farthest edge of the Earth, there is a continent that feels almost unreal. A world of endless ice, violent wind, frozen silence, and beauty so vast it seems untouched by time. This is Antarctica, the coldest and most mysterious continent on our planet. From above, it looks peaceful, a white wilderness stretching beyond the horizon, pure, quiet, and empty. But this beauty hides one of the most extreme environments on Earth. Here, temperatures can fall far below human limits. Winds can sweep across the ice with brutal force. Storms can erase the landscape within minutes, turning sky, ground, and horizon into one endless wall of white. Antarctica does not welcome life easily. It tests everything that enters. A single mistake can become dangerous. A hidden crack in the ice can drop hundreds of meters into now darkness. A calm coastline can suddenly break apart. Even the ocean around the continent is a warning, the Southern Ocean. One of the roughest and most unpredictable seas in the world, and yet this frozen land is not lifeless. Along its coastlines, penguins march across the ice in search of food. Seals rest near broken floes. Whales travel thousands of miles to feed in cold, nutrient-rich waters. Beneath the surface, tiny krill support an entire world of life. In a place that seems impossible, survival continues. But Antarctica is more than a land of ice and animals. It is a living archive of Earth's history. Locked inside its frozen layers are ancient air bubbles, climate records, and clues from a world long before human civilization. Scientists come here to understand the past, but also to read the future. Because what happens in Antarctica does not stay in Antarctica. When ice shelves weaken, glaciers move faster. When oceans warm, the frozen edges begin to change. And when Antarctica changes coastlines around the world, may one day feel the impact. Beneath this ice, there are hidden mountains, ancient valleys, and lakes sealed away for millions of years. Could life exist there in darkness and pressure? What secrets are still buried beneath the frozen surface? Antarctica is beautiful, but never gentle. Silent, but never still. Frozen, but constantly changing. This is the story of a continent at the edge of survival, a place where beauty meets danger, and where every question leads deeper into the unknown. To understand Antarctica, we must first understand its isolation. This is not just a cold place at the bottom of the planet. It is a continent separated from the rest of the world by distance, ocean weather, and time. Antarctica sits alone, surrounded by the Southern Ocean, one of the roughest bodies of water on Earth. No highways lead here. No cities rise from its frozen plains. No forests soften its horizon. There are no permanent towns, no ordinary streets, no human civilization built into the landscape. For most of history, Antarctica was not a home. It was a blank space on the map, a white mystery beyond the known world. Even today, with aircraft, satellites, research stations, and modern survival equipment, Antarctica remains deeply remote. It is not remote only because it is far away. It is remote because everything about it resists human comfort. The cold limits movement. The wind controls visibility. The ice decides where people can travel. The ocean decides when ships can arrive and when they must leave. Here, time itself feels different. During parts of the year, the sun does not set. It circles the horizon for weeks, covering the ice in a strange, endless light. In other seasons, darkness settles over the continent for months, turning the world colder, quieter, and more intense. This rhythm of light and darkness shapes everything. The animals along the coast, the scientists inside research stations, and the expeditions that depend on narrow windows of safe travel. From above, Antarctica may look simple, a vast white continent at the edge of Earth, but that simplicity is deceptive. Beneath the ice are mountains, valleys, lakes, and ancient rock formations hidden from human sight. Above the ice, the landscape can change without warning. A calm plain can become dangerous when the wind rises. A visible horizon can disappear inside a wall of snow. A coastline can shift as sea ice breaks apart and drifts into open water. This is why Antarctica creates such a powerful feeling. It looks empty, but it is not dead. It feels silent, but it is not still. It appears untouched, but it is constantly being shaped by forces larger than human life. The only human presence here is temporary. Research stations stand like small outposts in a frozen empire. Inside them, scientists study climate, ice, oceans, biology, geology, and the secrets locked beneath the surface. Outside, every movement must be planned. Weather must be checked. Equipment must be protected. Communication must be maintained. In Antarctica, survival is not about strength alone. It is about preparation, patience, and respect. This continent strips the world down to its most basic elements: ice, wind, ocean, darkness, light, and life, fighting to endure between them. There is no excess here. Nothing is casual. Every creature must adapt. Every human step must be calculated. A ship beside an iceberg looks small. A station beneath the polar sky looks fragile. A person walking across the snow becomes only a dark point in an endless field of white. Antarctica reminds us that there are still places on Earth where nature has not been softened, crowded, or redesigned for human needs. It does not invite comfort. It does not offer easy access. It does not explain itself quickly. Before we can understand its glaciers, its wildlife, its hidden lakes, or its role in Earth's future, we must understand this first truth. Antarctica is not just the end of the world. It is a world of its own. After isolation, the next truth of Antarctica is climate. This is not weather in the ordinary sense. It is not simply cold air, heavy snow, or a storm passing across the land. In Antarctica, climate is the ruling force. It decides when humans can move, when aircraft can land, when ships can approach, and when even the strongest machines must stop. Antarctica is one of the coldest, driest, and windiest places on Earth. From the outside, it may look still like a frozen world locked in silence, but that stillness is deceptive. The air is active, the ice is under pressure. The wind can reshape the snow within minutes, and when storms arrive, the entire landscape can disappear. One of the most powerful forces here is the katabatic wind. It begins high on the interior ice sheet where the air becomes extremely cold and dense because cold air is heavier. It slides down from the high plateau toward the coast. As it falls, it gains speed, turning into a fast-moving river of air across the ice. These winds can become violent. They sweep loose snow across the surface, reduce visibility, and make even simple movement dangerous. For researchers, a short task outside a station can quickly become a serious challenge. Equipment must be secured, routes must be marked, communication must remain clear. In Antarctica, danger often begins quietly. Then comes the whiteout, one of the most disorienting conditions on the continent. During a whiteout, the sky, the ground, and the horizon merge into one field of white. Shadows disappear, distance becomes impossible to judge. A person can stand in place and lose all sense of direction. What looked like familiar ground minutes earlier can become a blank, endless maze. The cold adds another layer of danger. Antarctica is cold, not only because it is covered in ice, but also because much of the continent sits on a high frozen plateau. The ice reflects sunlight back into space, while the dry air holds very little warmth. In this environment, exposed skin can freeze quickly, batteries lose power faster, metal becomes difficult to handle, and the human body burns energy just to stay warm. Here, warmth is not comfort. Warmth is survival strategy. Clothing, shelter, food, fuel, and movement must all be planned carefully. Every layer matters. Every exposed gap matters. Every mistake becomes bigger because the environment gives very little room for recovery. Antarctica is also a desert, though it does not look like one. Much of the continent receives very little precipitation. The air is so cold that it holds almost no moisture. Snow remains for centuries, not because it falls constantly, but because it rarely melts. This creates a strange contradiction. Water is everywhere as ice, but liquid water is rare and precious. Blizzards can transform this frozen desert in minutes. Wind lifts snow from the ground and drives it through the air until there is no clear difference between falling snow and blowing snow. Sound becomes muffled, visibility collapses, and the world narrows to only a few meters. In moments like this, modern technology helps, but it does not remove the power of the environment. This is why Antarctica tests the mind as much as the body. The cold is difficult, the wind is exhausting, but the deeper challenge is uncertainty. Weather can change quickly. Help may be far away. A safe route can become unsafe. A simple delay can affect an entire mission. For the scientists who live and work here, the climate shapes every detail of daily life. Outdoor research must be timed carefully. Instruments must survive extreme cold. Supplies must be protected. Vehicles must be maintained with precision. Even ordinary routines become part of a larger survival system. And yet, This harsh climate is also what makes Antarctica so valuable. The same cold that makes life difficult also preserves some of Earth's most important records. Deep within the ice are trapped bubbles of ancient air, layers of snow, volcanic dust, and chemical traces from climates that existed long before modern human history. Antarctica's climate protects these records because it is so extreme, so cold, and so isolated. In that sense, the continent's harshness is not only a threat, it is also a key to understanding the planet. Here, nature does not compromise. It does not adjust itself to human comfort. It sets the terms and everything else must respond. Before we reach the ocean that guards Antarctica, before we stand before its ice walls, and before we follow its glaciers toward the sea, we must understand the force that rules them all. A climate cold enough to preserve the past, harsh enough to test the present, and powerful enough to shape the future of the frozen continent. Before Antarctica appears as a frozen continent on the horizon, it reveals itself through the ocean. A vast, restless ring of water surrounds the land of ice, separating it from the rest of the world. This is the Southern Ocean, one of the most powerful and unpredictable marine regions on Earth. The Southern Ocean is not simply a passage to Antarctica. It is a barrier, a gatekeeper, and a warning. Every ship that travels south must cross these waters before reaching the continent. Here, the familiar world begins to disappear. The air grows colder, the waves become heavier, and floating ice starts to appear on the dark surface of the sea. For centuries, sailors feared this ocean. Unlike many other seas, there are few land masses to slow the wind. Storms can travel across huge distances without interruption, building waves that rise suddenly and strike with tremendous force. A calm surface can change quickly, turning into violent water within minutes. Even with modern ships, satellite data, and weather forecasts, the Southern Ocean still demands caution. At the center of this ocean is the Antarctic Circumpolar Current, the strongest ocean current on the planet. It flows endlessly around Antarctica, connecting the Atlantic, Pacific, and Indian Oceans into one massive system. This current helps keep Antarctica isolated from warmer waters farther north, allowing the continent to remain colder and more extreme than any other place on Earth. But the Southern Ocean does more than protect Antarctica. It also helps regulate the global climate. Its waters absorb heat and carbon from the atmosphere, move cold water around the planet, and influence weather patterns far beyond the polar region. What happens here does not stay here. A change in the Southern Ocean can affect sea levels, ocean circulation, marine ecosystems, and climate systems around the world. For explorers, however, the first concern is survival. The Southern Ocean is famous for its powerful winds and massive swells. Waves can lift ships, strike their sides, and make even large vessels feel fragile. Icebergs drift silently through the water, sometimes appearing like white mountains in the fog. But what rises above the surface is only a small part of their true size. Most of the ice remains hidden below, making them both beautiful and dangerous. Sea ice adds another layer of uncertainty. It expands, cracks, moves, and disappears with the seasons. A route that looks open one day may be blocked the next. A channel through ice can close behind a ship. In this ocean, maps and forecasts are useful, but they are never enough. The environment changes constantly, and access to Antarctica depends on timing, preparation, and respect. Yet, beneath this harsh surface, the Southern Ocean is full of life. Cold, nutrient-rich waters rise from the deep, feeding tiny organisms that support one of the most important food webs on Earth. At the center of this system is krill, small shrimp-like creatures that sustain penguins, seals, seabirds, and whales. This is one of Antarctica's great paradoxes. The ocean is dangerous for humans, but incredibly productive for wildlife. Penguins dive beneath the ice to hunt. Seals move between frozen floes. Whales travel thousands of miles to feed in these cold waters. In a place that seems hostile and empty, the sea becomes a source of abundance. The Southern Ocean is also a warning system. As the ocean absorbs more heat, warmer water can move beneath Antarctica's floating ice shelves. From above, the ice may look stable, but from below, it can begin to melt. This hidden melting weakens the ice shelves that hold back glaciers on land. If those glaciers move faster toward the sea, the impact can reach far beyond Antarctica. This is why scientists study the Southern Ocean so closely. They measure temperature, currents, sea ice, salinity, and changes in marine life. Each signal helps reveal how the frozen continent is responding to a changing planet. The Southern Ocean is both shield and messenger. It protects Antarctica from the warmer world, but it also carries the signs of global change directly to its frozen edges. It is dangerous alive and deeply connected to Earth's future. To understand Antarctica, we must first cross the ocean that guards it, because before the ice walls rise, before the glaciers move, and before the silence of the continent begins, there is the Southern Ocean, a moving frontier where wind, water, ice, and life decide who can enter the frozen world. After crossing the Southern Ocean, Antarctica reveals its first true face. Not a beach, not a forest, not a welcoming coastline, but a wall of ice rising straight from the sea. These are the ice walls of Antarctica, massive frozen cliffs of blue and white that stand between the continent and the ocean. From a distance, they look solid and permanent. Their surfaces glow under the polar light, marked by cracks, sharp edges, and layers formed over centuries. But this stillness is an illusion. These walls are not fixed. They are moving, cracking, melting, and changing under the pressure of gravity, ocean water, and time. Their story begins far inland, where snow falls across the Antarctic interior year after year. Over time, each new layer buries the one beneath it. The snow compresses, air is squeezed out, and slowly it becomes dense ice. Under its own enormous weight, this ice begins to flow outward from the high interior toward the coast. When the moving ice reaches the sea, it can extend over the water and form huge floating platforms called ice shelves. At the edge of these shelves, where the ice meets the open ocean, towering cliffs appear. These are the ice walls, the frozen border between Antarctica's hidden interior and the restless Southern Ocean. Standing before them, the first feeling is scale. A ship looks small beside these cliffs. A human figure would almost disappear. Some walls rise like frozen towers. Their faces are carved with vertical fractures and glowing blue bands. That blue color comes from old compressed ice. It is the color of pressure, age, and time. But these walls are more than scenery. They are natural archives. Inside the ice are trapped air bubbles, dust, volcanic ash, and chemical traces from ancient atmospheres. Scientists study these layers to understand how Earth's climate changed long before modern civilization. In this way, an ice wall is not just a wall. It is a frozen record of the planet's past. Yet, the same ocean that shapes these cliffs can also weaken them. Warmer water can move beneath floating ice shelves and melt them from below. From above, the wall may still look strong, but underneath its foundation may already be thinning. This hidden melting is one of Antarctica's most important warning signs. When stress builds inside the ice, a section can suddenly break away. This process is called calving. A huge block of ice can crack, collapse, and crash into the ocean, creating waves and releasing a new iceberg into the sea. Calving is natural, but when it becomes more frequent or more extreme, scientists pay close attention. This matters because ice shelves help slow the glaciers behind them. They act like frozen barriers holding back inland ice. When an ice shelf weakens, glaciers can move faster toward the ocean. Over time, this sends more ice into the sea and can affect sea levels far beyond Antarctica. Even here, in a place that looks lifeless, the ice walls are connected to life. Around the base of the cliffs, cold water and melting ice can bring nutrients into the ocean. Algae, krill, fish, penguins, seals, and whales all depend on the productivity of these polar waters. This is the paradox of Antarctica's ice walls. They look motionless, but they are always changing. They look empty, but they help support life. They look eternal, but they can fracture without warning. The ice walls of Antarctica are guardians, archives, and warning signs. They mark the place where land meets ocean, where beauty meets danger, and where Earth's frozen past begins to speak about its future. Beyond the ice walls, deep inside the frozen continent, Antarctica is shaped by one of the most powerful forces on Earth, glaciers. They may look still from a distance like frozen rivers trapped in time, but they are constantly moving, slowly carrying ice from the heart of the continent toward the sea. Antarctic glaciers begin with snow. Year after year, snow falls across the interior and builds up in thick layers. Over time, the weight of new snow presses down on the layers below. Air is squeezed out. Crystals change, and the snow slowly becomes dense glacial ice. Once enough ice forms, gravity begins to pull it outward. This movement is slow but unstoppable. Some glaciers move only a few meters each year. Others can flow much faster, especially when they approach the coast. From above, they look like wide frozen highways stretching across the white continent, carrying enormous amounts of ice toward the ocean. But glaciers are not smooth or simple. Inside them, pressure builds constantly. Ice bends, cracks, and shifts as it moves over hidden land beneath the surface. This creates deep fractures called crevasses. Some are visible as dark lines across the ice, but others are hidden beneath thin snow bridges. For explorers and researchers, this makes glacier travel extremely dangerous. What looks solid can suddenly give way. As glaciers move closer to the coast, they begin to change. The ice may thin, speed up, and feed into floating ice shelves. These shelves help hold back the glaciers behind them, slowing the movement of inland ice. But when the ocean warms, even slightly, warmer water can melt the underside of these shelves. When that happens, the glaciers behind them may begin to move faster toward the sea. This is why scientists study Antarctic glaciers so carefully. They are not just frozen landscapes. They are part of a global system. If large glaciers lose stability, they can send more ice into the ocean and contribute to rising sea levels around the world, a change that begins deep in Antarctica can one day affect coastlines thousands of miles away. Glaciers also carry the memory of Earth's climate. Inside their layers are tiny bubbles of ancient air trapped long before modern civilization. By drilling ice cores, scientists can study past temperatures, greenhouse gases, volcanic dust, and atmospheric changes. Each layer of ice is like a page in a frozen history book, helping us understand how the planet has changed over hundreds of thousands of years. Even life is connected to these glaciers. When glacial meltwater reaches the ocean, it can carry nutrients into the sea. These nutrients help support plankton, krill, fish, seals, penguins, and whales. In this way, glaciers do not only shape the land, they also help feed the living world around Antarctica's coast. The glaciers of Antarctica are silent, but they are not inactive. They move without sound, reshape the continent without warning, and hold records from a world long before us. They are builders, archives, and warning signs at the same time. To understand Antarctica, we must understand its glaciers. They are the slow engines of the frozen continent, carrying the past toward the sea and quietly shaping the future of the planet. Beneath Antarctica's endless ice, there is another world few people ever see. A world of mountains, valleys, and ancient rock buried under kilometers of frozen cover. From above, the continent may look like one vast white surface, but underneath it lies a rugged landscape shaped over millions of years. Some mountains rise above the ice like dark islands in a frozen sea. These exposed peaks, called nunatak, give scientists rare access to Antarctica's hidden geology. But many mountain ranges remain completely buried. Using radar and seismic technology, researchers have discovered peaks, ridges, and valleys beneath the ice sheet. revealing that Antarctica is not just a continent of ice, but a continent of hidden stone. One of the most important ranges is the Trans-Antarctic Mountains, stretching across the continent and dividing East Antarctica from West Antarctica. These mountains are ancient, and their rocks hold clues to a time when Antarctica was very different from today. Long before it became a frozen desert, the continent was connected to other land masses and had a much warmer past. These hidden mountains also help control the movement of the ice. As glaciers flow across the continent, buried ridges and valleys guide their direction. Some mountains slow the ice down. Others channel it toward the sea. In this way, the land beneath the ice quietly shapes the future of the ice above. The exposed mountain regions are among the harshest environments on Earth. Winds are fierce. Temperatures remain far below freezing. Life is almost absent. Only the toughest microorganisms can survive on the rocks. For scientists, this makes Antarctica's mountains valuable natural laboratories for studying the limits of life in extreme conditions. The mountains of Antarctica are more than frozen scenery. They are the hidden backbone of the continent. They preserve ancient history, control the flow of glaciers, and remind us that beneath the silence of the ice, Antarctica still holds a world waiting to be fully revealed. At first glance, Antarctica looks almost lifeless. A frozen continent of white silence, violent wind, and endless ice. But along its coastlines and beneath its surrounding waters, life exists with surprising strength. Here, survival depends on the ocean. The land itself offers almost nothing. No forests, no grasslands, no soil rich enough to support large life. But the Southern Ocean is different. Its cold, nutrient-rich waters feed as one of the most important ecosystems on Earth. At the center of this system is krill, tiny shrimp-like creatures that may seem insignificant on their own. Yet, they support almost everything around Antarctica. Penguins eat them. Seals hunt in the same waters. Whales travel thousands of miles to feed on them. Without krill, much of Antarctica's wildlife would struggle to survive. Penguins are among the most recognizable animals of this frozen world. They move across the ice in large colonies, walking, sliding, and gathering near the sea. Their lives are shaped by timing. They must breed, protect their young, and find food in one of the harshest environments on the planet. Every journey between the colony and the ocean is a test of endurance. Seals also depend on the ice. Some rest on floating floes, while others dive beneath the surface to hunt fish, squid, and krill. Their bodies are built for the cold, with thick layers of fat that help them survive in freezing water. For them, sea ice is not just a platform. It is shelter hunting ground and part of their survival system. Then there are the whales. During feeding seasons, great whales enter Antarctic waters to take advantage of the ocean's abundance. Beneath the dark surface, they follow the movement of krill and rise through the cold water to breathe. Their presence shows how powerful this ecosystem can be. Even the largest animals on Earth are connected to some of the smallest. But life here is never easy. Darkness can last for months. Storms can strike without warning. Sea ice expands and retreats with the seasons. A small change in temperature, ice cover, or food supply can affect entire colonies and migration patterns. This is why Antarctica's wildlife is both strong and fragile. These animals are perfectly adapted to the cold, but they depend on balance. If the ocean changes, if sea ice becomes unstable, or if krill populations decline, the effects can move through the entire food web. Antarctica may look empty from a distance, but at the edge of the ice, it is alive. Penguins, seals, whales, seabirds, fish, and krill all form a system shaped by cold timing and endurance. In this frozen world, life does not survive because the environment is gentle. It survives because it has learned to move with the rhythm of ice, ocean, darkness, and light. Beneath Antarctica's frozen surface, there is a world almost completely hidden from human eyes. Under kilometers of ice lie ancient valleys, buried landscapes, and lakes sealed away from sunlight for millions of years. One of the most mysterious of these places is Lake Vostok. Hidden beneath more than 4 kilometers of ice, it is one of the largest subglacial lakes on Earth. From the surface, there is no visible sign of it, only ice, wind, and silence. But far below, liquid water may still exist in darkness, pressure, and extreme cold. For scientists, Lake Vostok is more than a lake. It is a possible time capsule. Because it has been isolated for so long, it may contain clues about ancient environments and possibly even microscopic life that has survived without sunlight. If life exists there, it would have adapted to one of the most extreme conditions on the planet. This is why Antarctica's hidden lakes are so important. They help scientists ask one of the biggest questions in biology: how far can life go? Can organisms survive without light cut off from the surface beneath crushing ice and freezing temperatures? And if life can survive, there could similar life exist beyond Earth. Beneath the icy surfaces of moons like Europa or Enceladus. Studying these lakes is difficult. Drilling through the ice takes years of planning, advanced equipment, and extreme care. Scientists must avoid contaminating the water below. Because these environments may have remained untouched for millions of years. One mistake could disturb a world that has been sealed away longer than human civilization has existed. The existence of these lakes also changes how we see Antarctica. The continent is not just a dead frozen surface. Beneath the ice water can move. Pressure can shape hidden systems. Ancient landscapes can remain preserved in darkness. What looks empty from above may contain complex secrets below. Lake Vostok is only one part of this hidden world. Across Antarctica, scientists have found many subglacial lakes and water systems beneath the ice sheet. Some may connect to each other. Some may influence how glaciers move. Water beneath the ice can reduce friction, allowing ice above it to slide more easily toward the sea. So these hidden lakes are not only scientific mysteries, they may also affect the movement and stability of Antarctica's ice. What happens far below the surface can influence what we see above it. Antarctica's hidden lakes remind us that the continent still holds secrets beyond imagination. Beneath the silence, there may be water. Beneath the water, there may be life. And beneath the ice, there may be answers to questions that reach far beyond Antarctica itself. In this frozen world, the greatest mysteries are not always found on the surface. Sometimes they are buried deep below, waiting in darkness. Antarctica is not only a frozen wilderness, it is one of the most important climate laboratories on Earth. Beneath its silence, inside its ice, the planet has stored a record of its own past. Every layer of Antarctic ice tells a story. Snow falls, settles, and becomes buried by new snow. Over time, it compresses into ice, trapping tiny bubbles of air inside. These bubbles contain samples of ancient atmospheres preserved from times long before modern human civilization. For scientists, this ice is like a frozen archive. By drilling deep into the ice sheet and extracting ice cores, researchers can study temperature changes, greenhouse gases, volcanic dust, ocean patterns and shifts in Earth's climate over hundreds of thousands of years. Few places on the planet hold such a clear record of environmental history. This is why Antarctica matters far beyond the polar region. It helps us understand how Earth's climate worked in the past, how it is changing now, and what may happen in the future. The continent may seem distant, but the information locked inside its ice is connected to every coastline, every ocean, and every climate system on Earth. The Southern Ocean also plays a major role. It absorbs heat and carbon from the atmosphere, moves cold water around the planet, and helps regulate global circulation. But this same ocean can also carry warmer water toward Antarctica's ice shelves, melting them from below. What happens in the ocean directly affects the stability of the frozen continent. Scientists study these changes carefully. They measure ice, thickness, glacier movement, ocean temperature, sea ice coverage, snowfall, wind patterns, and atmospheric chemistry. Every measurement helps build a clearer picture of how Antarctica is responding to a warming world. The concern is not only that ice is melting, the deeper concern is balance. Antarctica's ice shelves help slow glaciers. Sea ice helps support wildlife. Cold ocean currents help regulate climate. When one part of the system changes, the effects can spread through the entire environment. This makes Antarctica both a record keeper and a warning system. Its ice tells us what happened in the past, while it's changing glaciers, coastlines, and ocean conditions. Show us what may be coming next. The continent may look frozen and still, but scientifically it is one of the most active places on Earth. It is constantly recording, reacting, and revealing signals of planetary change. To study Antarctica is to study Earth itself. Its ice holds memory. Its ocean carries warnings. Its glaciers show movement. And its future may help us understand the future of the entire planet. In Antarctica, humans are not owners of the land. They are temporary visitors. No cities rise from the ice. No permanent civilization has grown here. The people who come to Antarctica arrive for one reason: to study, explore, survive, and understand a world that does not easily allow human presence. Across the continent, research stations stand like small outposts in a frozen wilderness. Inside them, scientists study climate, ice, oceans, wildlife, geology, astronomy, and the secrets buried beneath the surface. Their work may seem quiet from the outside, but every discovery made here can help explain something much larger about Earth's past and future. Life inside these stations is shaped by discipline. Food, fuel, equipment, communication, and medical support must all be planned carefully. A small failure in an ordinary place might be easy to fix. In Antarctica, the same failure can become serious. Distance makes everything harder. Weather can delay flights. Storms can stop travel. Extreme cold can damage machines and slow even the simplest tasks. Outside the stations, the rules are even stricter. Researchers cannot move freely without preparation. Routes must be checked. Weather must be monitored. Protective clothing must be worn correctly. Teams must stay in contact. A short journey across the ice can become dangerous if visibility drops or wind conditions change. This is why Antarctica has always tested human limits. For early explorers, it was one of the final frontiers on Earth, a place where courage often met suffering and uncertainty. Today, technology has changed the way people work here. Satellites, aircraft, GPS, heated shelters, and advanced equipment make research safer than before. But they do not remove the danger. Antarctica still demands respect. The isolation can also affect the mind. Months of cold darkness, limited space, and separation from the outside world create pressure that is difficult to understand from far away. In winter, some research teams live in near total isolation. The sun may disappear for long periods. The landscape outside becomes dark, frozen, and silent. In that environment, teamwork, routine, and mental strength become part of survival. Yet, people continue to come because Antarctica offers knowledge that cannot be found anywhere else. Its ice preserves ancient climate records. Its clear, dry atmosphere supports scientific observation. Its remote ecosystems reveal how life adapts under extreme pressure. Its frozen landscapes help scientists study changes that may affect the whole planet. But perhaps the most important lesson Antarctica gives humans is humility. Here, even the best technology feels small. A research station can seem fragile under the polar sky. A vehicle crossing the snow looks tiny against the endless white. A person standing on the ice becomes only a small figure inside a continent of silence. Antarctica does not welcome humans in the usual sense. It tolerates them only when they come prepared, careful, and respectful. Every expedition is a reminder that this continent belongs first to ice, wind, ocean, and time. Humans may study Antarctica, but they do not control it. They enter for a while, learn what they can, and leave. The frozen world remains larger, older, and more powerful than anything built upon it. Antarctica may look permanent, but it is not fixed. Its ice, ocean, wind, and wildlife are all part of a delicate system. And when one part begins to change, the effects can move through the entire continent. One of the biggest concerns is the warming ocean. From above, Antarctica's ice shelves may still look strong, but beneath the surface, warmer water can slowly melt them from below. This hidden melting weakens the ice shelves that help hold back glaciers on land. When those shelves become thinner or break apart, the glaciers behind them can move faster toward the sea. This matters far beyond Antarctica. More ice flowing into the ocean can contribute to rising sea levels, affecting coastlines around the world. A change that begins in a remote, frozen continent can eventually reach cities, ports, islands, and coastal communities thousands of miles away. Sea ice is also changing, and this affects wildlife directly. Penguins, seals, krill, and many other species depend on the seasonal rhythm of ice. When sea ice forms, later melts earlier, or becomes unstable, feeding and breeding patterns can be disrupted. In Antarctica, timing is survival. If food appears too late or ice disappears too soon, entire colonies can feel the pressure. Krill are especially important. These tiny creatures support much of the Antarctic food web. Penguins feed on them. Seals depend on them. Whales travel long distances to reach the waters where krill gather. If warming oceans or changing ice conditions affect krill populations, the impact can spread quickly through the ecosystem. But climate change in Antarctica is not always dramatic at first. It may appear as a small shift in ocean temperature, a shorter ice season, a faster moving glacier, or a crack spreading across an ice shelf. These changes can seem quiet, but together they reveal a deeper transformation. This is why scientists continue to monitor Antarctica so closely. They track glaciers, ice shelves, ocean currents, snowfall, wind patterns, sea ice, and wildlife populations. Each piece of data helps reveal whether the frozen continent is staying in balance or slowly moving toward a new state. Antarctica is not just a victim of climate change, it is also a warning system. Its ice records the past, while its changing edges show what may happen in the future. The continent responds slowly, but when major changes begin, they can be difficult to reverse. The lesson of Antarctica is not only about ice, it is about connection. The ocean connects to the glaciers. The glaciers connect to sea level. Sea ice connects to krill. Krill connect to penguins, seals, and whales. And all of it connects back to the climate system of the planet. Antarctica may be far from most human lives, but it is not separate from them. Its frozen silence carries signals that matter to the entire Earth. And as the balance between ice, ocean, and atmosphere begins to shift, the world must pay attention. Because Antarctica is not only changing itself, it is showing us how deeply connected our planet truly is. At the end of the Earth, Antarctica remains silent but never empty. Its ice holds the memory of ancient climates. Its ocean feeds life in one of the harshest places on the planet. Its glaciers move slowly toward the sea, shaping the future in ways we are only beginning to understand. This frozen continent is not only a place of beauty, it is a place of warning. Every cracking ice shelf, every shifting current, every changing season of sea ice reminds us that Earth's systems are connected. What happens here can reach far beyond the polar circle. And still, Antarctica keeps many of its secrets hidden. Beneath the ice are mountains. No one has walked across valleys, no one has seen, and lakes sealed away from sunlight for millions of years. In that darkness, there may be answers about Earth's past, the limits of life, and perhaps even the possibility of life beyond our world. For humans, Antarctica is a lesson in humility. We can study it, map it, measure it, and cross parts of it with modern technology. But we do not control it. The cold, the wind, the ocean, and the ice still decide the rules. That is why Antarctica matters. It reminds us that some places are too powerful to conquer, too fragile to ignore, and too important to misunderstand. At the edge of the world, beauty survives beside danger. Silence carries history. Ice becomes memory, and every question leads deeper into the unknown. This is Antarctica, the frozen frontier of our planet, a land of survival, mystery, and change.